So why do we have to rewrite rational expressions? So the reason why we have to rewrite rational expressions is to help us be able to solve different problems that involves rational expression. That's why. So and now the question becomes, so what are the examples of these rational expressions? So can we just start by defining a rational number? So everybody define, as a warm-up, define a rational number. That's the warm-up. Write it down, please. That is, you are writing the definition of a rational number. And then if you finish writing the definition of a rational number, then give one example. So the warm-up says, once again, let me repeat. Topic is rewrite rational equation stroke expression. Warm-up is define a rational number and give an example. Okay, so why do we do this? Why do we have to do it? So that takes us to the objective. So the objective is to enable us solve problems that involves rational number. That's why we're doing it. There are different problems in mathematics, but we need to know how to solve problems that involves rational number. So we need to know how to rewrite it, write it in different forms. Okay? So now let's review the warm-up. I need somebody to tell me what they wrote. I'm going to call names randomly. I'm going to Cameron, go. I'm starting with you. What did you write? A rational number is, yeah, go ahead.
I said a rational number is expressible or containing quantities that are expressible.
Okay, thank you. Next person, I'm going to call Sharon, go. Tell us, read exactly what you wrote. Sharon. Next person, Fode, go. Fode Kalon. What did you write as rational number?
I said a number that can be representative as a quotient of two integers.
Okay, sounds good. Thank you. All right. So now, here's what I will advise. You can Google the meaning of rational number and review what they said, and based on that, write the definition. Now, based on this, give us examples. So let's now focus on the examples instead of writing the long grammar. So I'm going to call another person, Alegna. Give us one example of a rational number.
0.333, and it keeps going on.
Okay, so I'm just going to be writing the examples that you guys tell me. 0.333 repeating. Next example. Next person, Daphne, go ahead. Example of another example of rational number.
I did 2x plus 3 over x minus 1.
Okay, you gave a rational expression. I just need a rational number, but thank you anyway. Next, Kelly. Kelly, go.
0.75.
Okay, I'm gonna write 0.75. Okay, now I have had the next rational number you give me will not be a decimal. So give me another rational number that is not a decimal. Ivan, go.
12 over 17.
Okay, so 12 divided by 17. Thank you. So now, can a rational number be a whole number? Is a whole number a rational number?
Yes.
Yes, it is. So you can give me an example of a whole number. It can be 1, it can be 2, it can be any whole number. Any integer, whether positive or negative, is also what? A rational number. Okay? So now, having said that, let us just, so that we don't confuse ourselves, let us just give other examples that are not rational numbers. So I will draw a line here, and then we give other examples. I will call it irrational numbers. So give me some examples. I'm going to call name. Nayona, go. Give me one example of an irrational number.
Is pi an irrational number?
Yes, it is. So you're giving me a pi. I want you to answer it with confidence. You can only be wrong and then you'll be corrected.
Okay.
All right. So I take it that you say pi is an example. So if it is wrong, we'll correct it, okay? If we don't know it, we will seek for more information. So pi is what you just gave me. Okay, who else can give us another example of an irrational number? What?
Said 5.
5 is a whole number, and all whole numbers are
irrational. You said irrational number?
irrational. So now we are dealing with irrational number. We are dealing with examples of it now.
Square root.
Square root of what?
Square root of 5.
Of 5, okay, that could be. Square root of 5 could be. Square root of 5, it could be. Now we can verify. Here's how to verify it. If we check the square root of 5 right now, if it gives us a decimal and there is no repetition on the decimal, then that's an irrational number. If there is a repetition of the decimal, then that's a rational number. So let's check square root of 5 right now. So I'm going to pull out my calculator. So let's say square root of 5. This is square root 5. Then come out of the square root and then you hit enter. Boom. So you see, this is 2.2360679. So this is an irrational number. Okay. So by the way, not all square roots are irrational number. For example, let's do square root of 16 and see. Second function, square root, and then we write 16 and we hit enter. Boom. What does it give us? It gives us 4. So square root of 16 is not an irrational number. Square root of 16 is a rational number. All right. So let's get back to our screen and give at least one more example. Okay, give us one more example of an irrational number, then we close that chapter.
The square root of 2.
Okay, that's another example, square root of 2. All right, so now there are so many irrational numbers out there. There are so many rational numbers out there. So now, since we now know what rational numbers are and some examples of irrational numbers, now let's get to rational expressions. Let's get to rational expressions. So how do we get there? Rational expressions, or you can say equations. It doesn't mean that equation and expression are the same. They are not. but we have to use both of them together. Now, everybody draw a very nice rectangle. Draw a very nice rectangle and label it as area, as length and width. And then, what's the formula of a rectangle? To find the area of a rectangle, the formula.
What?
Area is equal to length times width. Okay? Now, here's the question, and I'm going to give you 20 seconds to solve it. By the way, write your solution down. Solve for W. So, given area equal to length times W, solve for W. 20 seconds.
Do we just say it?
Okay, go ahead and say what you have.
Area.
W equals A divided by L.
Thank you. So solution is, so A divided by L equal to L multiplied by W divided by L. So you're just dividing both sides by L because you want to isolate W. And you end up having that W is equal to the area divided by the length. Okay? Now, let's do another very easy example. Everybody draw a circle. Draw a circle. And in this circle, it has a radius. So now we are going to consider two formulas. One of it is circumference of the circle. So somebody give me the circumference of a circle. C equal to 2 times pi times what? Radius.
Squared. No, wait.
So, then how about area? Area of a circle.
Oh, he was talking about that. My bad.
R squared.
Yes, area is pi r squared. So these are the two things you're given. So now the question is going to be, for each of them, solve for radius. I'm going to give you 30 seconds. For each of these equations, solve for the radius. Given circumference equal to 2 pi r and area equal to pi r squared, solve for the radius.
Isn't the first one
Hold on. I'm going to call somebody who hasn't spoken.
okay?
Thank you.
No,
I appreciate the
enthusiasm.
yeah, the willingness to help us out. But let's see, everybody has to say something. Okay, I'm going to call name right now. Mohammedu, go ahead. What is the first one? Next, Joshua. Joshua, go ahead. What's the first one? Joshua.
You said what's the radius?
Yes, for the first one. Yes.
Isn't it A divided by pi square?
The first one is this one. The first one is
Oh.
the one that has to do with circumference. So
Isn't it just C divided by 2 and pi?
yeah, 2 pi. Okay, that's correct. So the first one is, this is C divided by 2 pi equal to 2 pi multiplied by radius divided by 2 pi. So that crosses out. and leaving you with radius equal to c divided by 2 pi. Next, let's go. Next person. Joseph, go. How about the second one, the one that has to do with area? Joseph, go.
What would you do? You divide by pi r, I guess. I don't know.
Yes. Go ahead. Yes, and then what's the next step after dividing by pi?
You divide area by pi r on both sides, and then the pi will cancel out.
So he's saying a over pi equal to pi over pi, and you're still and then radius squared. So he said pi will cancel out. Yes, go ahead. What's the next step now?
You'll have area equals what is that? R squared.
Yes, area over pi equal to r squared. So now we are not looking for r squared, we are looking for r.
I'm not sure what you would do next.
Okay, next, who is going to help us out from this point? Volunteer now. Somebody volunteer.
You can square root both sides.
Okay, so Yang said square root both sides. So square root a over pi equal to square root radius squared. And once you do that, the radius squared will now become radius. And then the other side is going to be square root of a over pi. And that becomes your solution.
Is it?